Scarab Squeeze, the entrancing red supermonster that enhances Orion's shoulder, is going through a momentous transformation. This heavenly Goliath, known for its splendid red tone, has been a foundation of the colder time of year sky for centuries, drawing the stunningness and marvel of stargazers from old developments to current cosmologists. What makes this change so exceptional isn't simply the change happening inside the star itself, but the sheer scale and velocity with which it is occurring. This enormous star, many times bigger than our Sun, is showing us just how dynamic and unusual the universe can be. Bug Juice's iridescence, the brilliant sparkle that characterizes its divine presence, has flooded past its standard brightness by a bewildering half. Imagine a light suddenly becoming twice as brilliant, projecting its gleam further and with greater force. That is what's going on with Betelgeuse on an inestimable scale. At the beginning of this year, Betelgeuse proudly held the distinguished title of the 10th most brilliant star gracing our nighttime material. Its consistent natural light was a steady in the night sky, a guide of security. However, this unforeseen divine explosion has propelled it to a esteemed new position, now sparkling splendidly as the 7th star in our rousing night sky. This jump in splendor has ignited fervor and interest within the cosmic community, inciting groundbreaking perceptions and studies to grasp the mechanisms driving this sensational change. Scarab Juju, a huge star in its late phases of life, is of enormous size. Its aspects are so large that if it were situated at the center of our solar system, it would extend out to Jupiter's orbit. Ultimately, this star will go through a breakdown, resulting in a powerful cosmic explosion, which might lead to the formation of either a neutron star or, alternatively, a black hole. The expectation surrounding Betelgeuse's cosmic explosion comes from the fact that it will be an exceptional event, situated roughly 650 light-years away. Mankind finds itself in an ideal position to observe this astronomical display firsthand. When the heavenly blast happens, it will produce a stunning showcase of light. At first, there will be an unexpected inundation of neutrinos that will sweep across the Earth, noticeable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of heavenly flotsam and jetsam, Betelgeuse will quickly increase in brightness over the course of 7 days, reaching up to 100,000 times its typical radiance. Depending on the blast's power, this heavenly guide could rival the brightness of a full moon and might even be visible during daylight hours, projecting noticeable shadows. At night, this grand event will last for an extended period, offering cosmologists an unrivaled opportunity for detailed observations and potentially pivotal revelations. While the cosmic explosion of Betelgeuse might trigger speculation and fear due to historical associations of such events with ominous signs, we can take comfort in the fact that we are securely positioned at a considerable distance, protected from any adverse effects. To fully understand the puzzler surrounding Betelgeuse, it is crucial to revisit the end of 2019. During this period, the red supermonster star began experiencing significant darkening, a change noticeable even to the naked eye. Observations using extremely large telescopes in the optical range revealed that Betelgeuse appeared generally stable, yet its photospheric layers showed signs of substantial disturbances. The photosphere represents the outer layer of the star where light is produced. Scientists also identified an expansion of the photosphere, giving the impression that the star was enlarging when viewed from Earth. This expansion continued at a steady rate of around 8 kilometers per second for most of the year until mid-November 2019, at which point the outward speed began to decline. By mid-November 2019, the flow of material from Betelgeuse stopped, prompting cosmologists to capture new optical images of the star. Their observations revealed two surprising inconsistencies. Firstly, an obscured region appeared on the star's southern side of the equator, starkly contrasting with a previous image taken at the start of the year. Secondly, the surface temperature of the star experienced a decline of around 80 Kelvin between January 27th and February 13th, 2020. The brightness of Betelgeuse reached an unprecedented low roughly a year after the end of the outpouring. However, the star gradually regained its brightness over the following months, eventually returning to its usual glory. This led to the question, what had actually occurred with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone a gigantic and remarkable event known as a surface mass ejection, SMME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better grasp SMME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior floods up and outwards, causing shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SMME resulted in the ejection of mass 400 billion times more than what is typically observed during similar events on other stars or CMEs. This amounted to many times the mass of the Moon, moving at astounding velocities. Scientists noted that such a colossal mass ejection from a star's surface had never been seen before. The event allowed for direct observation and assessment of surface details using the Hubble telescope, offering a real-time look into the aging and development of a dying star. The SMME had a significant impact on Betelgeuse, causing it to lose a vast amount of mass in a single event. This event demonstrated that a dying star can experience significant mass loss beyond its normal annual decline due to stellar winds, as if Betelgeuse had forcefully shed its upper layers and was now in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness at regular intervals, but now it is pulsating at different intervals. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple patterns of fluctuating brightness due to variations in its size and temperature. This red supergiant is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the primary mode, while the second period is a longer cycle of approximately 5.6 years, with its origin remaining unclear. In their research paper, scientists used virtual simulations to gain a deeper understanding of the events that occurred. They proposed that an unusually hot gas current resembling a massive and intense bubble rose from within the star. These events of hot gas bubbles occasionally emerge due to the star's turbulent and convective envelope, which can be compared to a pot of boiling soup, where the material is continually moving and mixing. As this hot air bubble rose and breached the star's surface, it triggered the release of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to shift from its regular 400-day pulsation to a new 200-day pulsation. Astronomers expect that the star's normal pulsation patterns will gradually stabilize over the next 5 to 10 years, eventually restoring Betelgeuse to its typical multi-day pulsation. Regarding the possibility of a Betelgeuse cosmic explosion, astronomers estimate that it could happen anytime within the next 10,000 to 100,000 years. Based on factors such as the star's variability, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process will continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational force, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any cosmic explosion event occurring now would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The remarkable aspect of Betelgeuse is that we can actually see its surface, which is not the case for most other stars. This provides us with an incredible opportunity to learn about how massive stars like Betelgeuse behave as they age, including these types of astonishing mass ejection events. Recently, astronomers made a surprising discovery when they observed a star consuming its own planet 12,000 light-years away in the constellation. Betelgeuse, with its captivating name and prominent position in the night sky, has fascinated human imagination for centuries. Its significance extends beyond scientific knowledge, as it has influenced pop culture and folklore around the world. Betelgeuse has a rich and diverse origin rooted in Arabic language, initially interpreted as the armpit of the giant. Some researchers argue that it may refer to a hand or shoulder. Regardless, this physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures. Furthermore, Betelgeuse carries multi-layered implications and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was seen as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse means the damp one, linked to Hindu astrology's Ardra lunar house and associated with the storm god Rudra. Historically, Betelgeuse has played a significant role in cultural practices and customs. For instance, in Macedonian tradition, it symbolized tamed animals and rural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse,